So, in this week, we will start with your encapsulation. But what's the meaning of the encapsulation in Python or in programming language? Encapsulation means that the data hiding mechanism in which we can store any variable for a given class and the other parts of code cannot see this feature. Okay, which means that if you want to hide any system or any mechanism, and then we need to use this encapsulation method. In Python, there are no section like private, public, or protected. Okay, in C++ we have these properties. Okay, because if you have these informations or these sections, and so we can define our variable on the private section or the public or protected, and so protected can reach the inherited class variables. Public can be reached by using the every data, but the private can only be used within the class. Okay, but we have some techniques to define these properties in the Python programming language. Okay, and so the x1, the class sample, can be defined with the constructor values of the terms. Okay, so we can add some another arguments just like this one, and so the self. We have the one underscore in here, just like this one, the A. Okay, and also that this can be used with the with the print self A. Okay, and also we can define the def foo self and print sample foo. Okay, these are the case. And so what's the meaning of the one underscore in here and double underscore in here before the writing the function name? Okay, and so the S sample can be built with the tab. And firstly, we need to test these algorithms just like this one. If we don't give any parameters in here, and so the interpreter or the Python compiler tell us what the one positional argument should be given to the init function, because it's the R constructor. Okay, so but if we take or if we give the 10 value in here, and so we can call this function just like this one, 10. Okay, we can see that. But we can also A just like this one. See the 10 in these parameters. And so how about this one? S dot A can be assigned with the 20 values, and as this function can also be called just like this one. We can assign these values in here. But what about this one? S foo. If I call the foo function in here, and so we define these properties in here, but we cannot reach these values because the sample object does not have the attributes of the underscore foo function in here. But what about this one? If we define the foo in here, and also we can call the foo function in here, just like this one. See, the 10 sample foo can be called, but the other parameters or the s variable, which is derived from the sample class, cannot reach these values. Okay, this is the error, and so we can say that this is the private definition of our class. Okay, but just see that this foo function can be called within the this function, because this self possesses this foo function. And so if you want to derive or to define the private object or the private attribute or the functions, and so we can use this syntax underscore blah blah blah. Okay, you get it right now? How we can specialize our functions or the attributes within a class in here. Do you understand that? Okay, yeah. So, in the second example, we need to talk about the polymorphism. Because it represents it represents the public variable definition. Normally, we can drive we can generate the variables just like this one with these definitions. Okay, yeah. But if you put the one underscore, it means that it's public, and so we can inform the coder to notice that this is a public variable. Yeah. Okay. But we will implement another examples related to this one. Do you get Yara right now? Yes, but we have one difference, and I will show this in later examples. Yeah. Okay. So polymorphism. What's the meaning of the polymorphism? We can create the employee class just like this one, and so the init can be called in here. See that we have the double underscore in here, which means that this is a public function, right? But we have also a double underscore in here. Okay, I will explain this later. Okay, but we need to put the name in here, and also class worker can be derived with the employees. Okay, and so the init can be given in here, name and surname should also be given in here, and also we can derive another variables, week hours. Okay, so the self week hours can be defined in here just like this one. Okay, after that we can build the calc salary self and return to the self work week hours times 30. Okay, this is the base rate or the base calculation for the salary for a given week hours. Okay. Class manager employee can also be derived, and def init name and surname, and also we can give the prim. Okay, so the name is assigned in here, and self prim is assigned with the prim. Okay, and def calc salary, it's the same name with the previous one, but the manager is derived from the employee, not the worker one. Okay, so the return, for example, 7,000 times self prim. Okay, this is the basic mathematical calculation. We don't mean anything in here. Okay. So we can also define the salesperson. Plus salesperson from employee. Okay, and so that init can also be given in here, and also we can give the prim to the salesperson prim. What's the meaning of the prim in English? I don't remember. right now. Def calc salary self and return 3000 plus 3000 bonus. Bonus. Yes. Thank you. Self trip. Okay. But we define the pair. We remain unchanged right now. Okay. So employee or employees can be generated with what within a list, but we need to give some worker in here. For example, Berk, Baran, and 40, and the manager is the what, the Berk Watan 0.20, and salesperson is the Mehmet, for example, Mehmet 0.1. Okay. And so we can define these terms, and for m in employees, which is written as the name, okay, and this one salary, and this one format map emp name and emp times calc salary. Okay, see, these employees contained in the what in one list, but this emp possess the what the calc salary in here. Okay. So if we run this algorithm, and so the emp name are the same for every data, but the calc salary creates what the three different functions in here, which is called the polymorphism. Okay, we call the same function, but we have different calculation in here. With one name we can use it, with one method we can use or build this function methodology. Okay, but this is called what the polymorphism in programming language. Do you get it, guys? Do you get it? Do you understand what I'm saying in here? Can anyone say yes or no? What's the polymorphism in here? Polymorphism means that we call the same calc salary function, but the calc salary at this rate, this is one different, other different, and the others different functions are given in here with the different objectives. But we can call what the emp calc salary. This is called the polymorphism, guys. Do you get it? Okay, Mara. Thank you, Mara. Thank you, Mara. And so, how we can employ this or use these properties? Employees' salary can be calculated with the what? With the emp calc salary. We can call the calc salary in here, just like this one. See that for each employees we have different calc salary function, but if we call the employees with the calc salary, we can easily find out the what is the total salary for the what the workers or the companies. The print total salary which is given with the what, with this one, and the format salary. Okay, so see, this is easy to what, to calculate the whole salary based on the what, the polymorphism feature. Okay, polymorphism feature. Any question about this? Yara, everything is okay? Okay. So we need to follow the what overloading mechanism, especially for the what operator one. For example, this overloading mechanism is just a kind of polymorphism, because we override some function, based on our purpose. Okay? For example, the class sample, right? The init. And so one can be assigned in here and self one. This init function is an overload or not? Just say it. No, this is an overload, the constructor overload. See that? Because we have the what as sample in here, just like this one. And so if we run this code, the sample init function missing one required positional arguments, and so we overload this mechanism in here, and so we cannot use the default constructor in here. Yeah, okay. Otherwise, we can generate this another sample parameters without the arguments. Do you understand that, Yara? This is a constructor overload. Okay, so what about this one? Anyone remembers the double str function in here? Self. Anyone remember that? Just see that we can return what the str values in here. Sample instance value is equals to the what? The format self.y, right? So how about this one? If we remove these terms and tell the print s is given us to what the main sample object at the some address points in here, right? That's it. This s generates to the what? To the our address, but a dynamic address related to sample class. Okay, but if we give this mechanism, this def str is given in here, just see that if we rerun this code, and then we will have the sample instance value, right? This is override the standard print definition or returning str value of the class. Okay. So if we add this mechanism just like this one, so returns to str if we define str function overload. Right now, do you understand what's the difference between these two methods, guys? Yara? Yes, okay. So we can specialize the our functions based on what are these overloading mechanisms, which we call it to the what? To the polymorphism. We can override any system based on these features, okay? Okay, str and repr methods. This is kind of the polymorphism, okay? We can create a class complex and def init can be given in here, but we need to give the what real and imag bodies in here, just like this one, okay? And so the self real can be initialized with the real, and so self imag is initialized with the what? With the imag, okay? So how we can specialize our str function in here? if we have the complex variable in here, just like this one, and so we can write the def str function with the self parameters. And so we can return to the what? Our real part and imaginary part times I that format of the what? The self, real and self image. Okay? And so the z can be defined with the complex values of the what? The 3 and 2, and so the print z can be written just like this one. See, 3 plus 2i is seen on this page. But if I remove these terms, and so we will have the address values of the main.complex objects in here. If you put this str function, and so this overload gives us a polymorphism feature. And so we can specialize our output based on these terms. Do you understand how we can handle or how we can use the advantage of these terms in here? Okay. So we can continue with what? With another functions in here. The 5. Okay. So if we want to define the date class, the init function body can be given here, and day, month, and year, returning values of the what to the none. Okay. So self day can be assigned with the day, and self month can be assigned with the month, and self year can be assigned with the year. Okay, and so we can specialize our str function with the what? With this term, the return these values, fancy parentheses, fancy parentheses, fancy parentheses. Okay, and so the format can be given with the self day, self month, and self year. Okay, so if we create any date in here, for example 10 or 11, 12, and 24, and so we can print these values just like this one. See, these are the date. And so what about this condition? What is the output of right now this code? What is the output of this code? Just see that if we rerun this code and then see currently str return the non-string key values in here, just like this one, and so this is an error. Error. It should return to the what? The string character, right? And so what about this one? That is your, and so the return this one. What's the return values of these terms right now? Yes, but we have to know about this one. This is an overload, and so if we want to design our str function, you need to implement everything you must see on the terminal. Okay, you must remember that, because there is no syntax error in this function utilization, but you need to put every data or every form of these terms just like this ones. Okay, any question? Because the str is already defined in the Python interpreter or the compiler. And so if we write this code, and so we can change the dynamic, or we can change the are properties of this class function. Yeah. This is why it's called the overload. Because already we have the str function. It returns to what the dynamic address values of the distance. Okay. So we need to continue with what another examples about the date. 6. So the class date def init can be built with what? Again, the day, month, and year. Okay, and so self day, self month, self year. Okay, so that repar is another function related to the what, the R operator overloading mechanisms. See them. Return date object, fancy parentheses, okay, and show the format of this term self day, self month, and self year. Okay, so what about this one? The date can be assigned with what 11, 12, 24. Okay, and so the print D. What is the return values of these terms just now? See, that object is given with the what? With a distance. Okay, and so what about this one? The print str D. See, this is also given to the what? The R basic methodology. Okay, so what about this one? Repar. See, this is the another utilization of what the repar methods in the what? In the overloading mechanisms of the what R str body. Okay, and so if we want to print any variable related to the date, either we can use the what, the str, or the repar, but we have some differences in here, but I will show you later this property. Okay, in the general overloading example. So we have also another important properties for methods, the del methods. What's the meaning of the del? Yara, what do you think about the del? From the name, yes, delete, and show the print in it the a constructor given here, and so the del also overloaded in here with a self. Okay, and so the print a destructor can be given in here. Okay, and so if I run this code, what is the output of this code? What is the output of this code? Yes, a constructor and a destructor is called right now. See? But if I remove this code, there is no syntax error in here. If I remove this code, there is no syntax error in here. Just like this one. Just remember that this is just like the destructor given in the C++. Okay? Yes, but we have some differences in here. And so I will create another example about this del, especially for the what the derivation mechanisms. Class A, def init self. This is print a constructor can be given in here, okay? And so def del self print a destructor. At every case, Donia, the del and init should be called, okay? Even if we derived another class in here, these properties are same with the C++. We must call to the what the constructor and destructor at every case, okay? Class B, A. What about we drive the classes based on what the A? Def init self super init and so the print B constructor, okay? And so del self the print B destructor, okay? And also we need to call the what super del, right? And so what about this code? If I run this code, what is the output of this code? What is A const B const B dash A dash B dash okay. Yes. In the first place, we call the B, and so the super init, the init function of B is called, and so super init is going to what the A constructor. After that, this is completed, and so the print B is run. And after that, if we don't have any process or the implementation, and so the destruction process is started. And so, in the first place, the print B destructor is called in here. After that, super del is given here. But what about this one? What about this one? Yes, now the A destructor and B destructor is turned into what another one. Order of calling is changed, right? Right? Okay. So what about this code? If I run this code, what happens? See, in this case, we have A constructor, B constructor, and B destructor. It's called in here, right? And so the super del is given in here, and B destructor can be called in here, just like this one. Okay, but what about the this code? What happens if I run this code? See, if we call this code, and so the super object can reach to the what to these values just like this one, okay? And so in this case we have to what to runtime error, because we don't have any del function in here. Do you understand how we can call the del and another functions in here? For example, we can generate the what to the another parameters in here about the del. So what about this one? What happens if I run this code? See? There's no error. But why? What happens if I run this code? Because the del is given in here, which means that if this is the case, the init function is always defined in compilers or interpreters, defined by the compilers, but del may or may not be defined by compilers. Okay, you must understand that. What about this one? See, the initial function or the init function are necessary, are unnecessary, or the may necessary or not for the what? For the destruction definitions. Okay, guys? Yara, do you understand that? The destruction calls at the what? At the end of. So this is not called by default only. No, the destructor at every case in the Python, destructor may or may not be called because the dynamic variables are always utilized in the program. Okay, because in this case we have everything in a dynamic form. Okay, and so the del can maybe called or not, but the constructor it always should be called. Okay, Donia, the del is the process to what? To remove the data. And so if you remove this data, automatically the class calls this function Yara. Okay, and so this can be useful to what? To terminate any variable in here. And so maybe we should print the what? The some warning to the what? To the user or the programmer. Okay, do you understand that, guys? Donia, Yara? A little. Okay, so we'll construct another example about this. But the initial function or the init function should be written on the what? On the compiler, but the del is not. If you want to use the del or if you define the del at the end of this variable, this del should be called by the interpreter. That's it. Okay. And so let's take a break and we will start at 2:05 p.m. Okay.